Hello everyone, welcome back to our channel Problematical. Let's discuss exercise 3.1 from class 11th Maths NCERT, chapters Trigonometric Functions. Find the radian measure of the corresponding corresponding to the following degree measures. Degree measures are given to you. You have to find the corresponding radian measures. We know that pi radian is equals to 180 degree, which means that 1 degree is equals to pi upon 180 radian. Using this, for the first part, 25 degrees is equals to 25 into pi upon 180 radian. This will be equals to 5 pi, it will be cancelled by 5. 5 pi upon 36 radians. Second, minus 47 degree, 30 minutes. We know that 1 degree is equals to 60 minutes. Therefore, half degree will be equal to 30 minutes. Dividing by 2 on both sides. This is equals to minus 47 degree into 1 by 2 degree, which is minus 47 1 by 2 degrees. This is equals to minus 95 by 2 degrees. Now 1 degree again is equals to pi upon 180 radian. So it is minus 95 upon 2 into pi upon 180 radian. Again, this can be reduced to minus 19 pi upon 72 radians. 5 19s are 536. Next, 240 degree. 240 into pi upon 180. 0.0646 into 3. 4 pi upon 3 radians. You can write the radians in complete words, or you can write the symbol C. 4. 520 degree. 520 into pi upon 180. 0 gets cancelled. 2 26. 26 pi upon pi radians. Okay. Next, find the degree measure corresponding to the following radian measures. Pi is equals to 22.7. Now degree measures are given to you. You have to find the corresponding radian measures. We know that pi radian is equals to 180 degree. Nothing is given. It is by default assumed as radian. Therefore, 1 radian is equals to 180 upon pi degree. One way you can remember these conversions, if you do not want to actually do it from pi is equals to 180 degree, you can save time by simple correlation or comparison. Whenever you're converting degree into radian, you want to convert something into radian. So pi is for radian, pi will be in the numerator. Whenever you have to convert something into degree, then 180 will be in the numerator, because 180 corresponds to degree and pi corresponds to radian. So that is like an analogy that you can use to remember the formulas. In the first part, you have to find 11 upon 16 radian. So this will be written as 11 upon 16 into 180 upon pi Pi value is 22 upon 7. 7 will be in the numerator. So now this can be reduced. 11 to 90, 45. So you end it up with 45 into 7, 315 upon 8. This is in degrees. You can convert this into mixed fractions by 8. So 315 divided by 8, and right then you'll get the remainder 3. 39, 3 upon 8. Quotient, remainder, divisor. Now you can try and convert this into, this is completely in degrees, so you can try and convert this fractional part into minutes and further into seconds if you like. 39 degrees and 3 upon 8 degrees. We know that 1 degree is equals to 60 minutes. So this is 39 degree, 3 into 60 upon 8. Again, 4, 1, 15, 2. This is equals to 39 degrees, 5.2. This is equals to 39 degrees. In fractional part, it will be 22. This is minutes. 22, 1 by 2 minutes. Again, splitting into 2, 39 degrees, 22 minutes into, we know that 1 minute is equals to 60 seconds. So 1 by 2 minutes can be written as 1 by 2 into 60 seconds. This is 39 degree, 22 minutes and 30 seconds. So that will be your final answer. Next. One second. Okay. So second part you have to calculate is minus 4. So minus 4 is minus 4 into 180 upon pi. We need it in degrees. That's why 180 in the numerator. Pi is 22 upon 7. So minus 4 into 180 upon 22 into 7 goes in the numerator. So 11 to 7. Now this can be multiplied, and after multiplication you get negative of 2520 upon 11. This should be converted into mixed fraction. This is in degrees. It can be converted into mixed fraction as minus 229 1 upon 11 degrees. Again, you can convert it into seconds. 1 degree is equals to 60 seconds. So you can write minus 229 degree 1 upon 11 into 60 minutes. Again, this can be further converted into minus 229 degrees. This is 5 minutes, 5 upon 11 minutes. Again, it can be written as, this minutes part can further be written in seconds by multiplying it by 60 again. This is minus 229 degrees, 5 minutes and approximately 27 seconds after calculation. Next, third part, 5 pi upon 3. This is 5 into, pi value is 22 upon 7. So this is 7 into 3. Now, what did we miss? We didn't write pi. Okay, yeah. This is in radians. 1 second. Made a mistake. Let's redo it. 5 pi upon 2 upon 3 into, you'll have to convert it into degrees. So 180 upon pi should be multiplied. Pi itself gets cancelled. 3. So you have 300 degrees. Fourth part, 7 pi upon 6. So 7 pi upon 6 is to be multiplied by 180 upon pi. Pi gets cancelled. 30. This is 210 degrees. Next. One second. Wheel makes 360 revolutions in 1 minute. Through how many revolutions does it turn in 1 second? So it takes 360 revolutions in 1 minute, and you have to find out the radian measure which it takes in 1 second. So let's calculate for 1 second. 360 revolutions in 1 minute. 1 minute is equals to 60 seconds. In 60 seconds, it is the wheel is revolving 360 times. In 1 second, it will revolve 360 upon 60 revolutions. That means 1 second is equivalent to 6 revolutions of the wheel. The wheel will take 6 revolutions. Through how many radians does it measure 1 second? Now we know that this is 6 revolutions. 1 revolution of the wheel is equals to 360 degree measure in degree measure is equals to 2 pi radians. Now we have to calculate in radians, so we'll consider this 2 pi radians. 1 revolution is equivalent to 2 pi radians. Therefore, in 1 second, the wheel is moving for 6 revolutions, which means 6 into 2 pi radians, which is 12 pi radians. That's your final answer. The wheel will move for 12 pi radians in 1 second. Okay. Find the degree measure of the angle subtended at the center of the circle of radius 100 centimeter by an arc length of 22 centimeter. So a circle is given to you. We are assuming this to be the circle. And then a degree measure of the angle subtended at the center of the circle of radius 100 centimeters. So this is the radius. And there's an angle subtended there's a 100-degree angle subtended. Let this be the 100-degree angle subtended at the center by an arc length. This is the arc length. Let this be ABC. So it's given that this is angle formed. Let it call be theta. So your theta is equals to angle EOC, which is equals to 100 degree, and your arc ABC is equals to 22 centimeter. This is not 100 degrees. Okay, hold on. Made a mistake. To find the degree measure of the arc subtended, theta value is to be calculated, which is angle AOC is to be calculated when your radius is equals to 100 centimeter and your this arc length is equals to 22 centimeter. So let this radius be R and this arc length be small l. So this is your L and R is given as 100 centimeter. Now we know that there's a relation between length of the arc, L, R and theta. So L is equals to R theta, which means your theta is equals to L upon R. Length is 22, radius is 100 centimeter. This is centimeter. Find the degree measure of the angle. So whatever angle from this formula that you'll get it in radians. Units will get nullified to 11 and to 50. We have to convert this theta is equals to 11 upon 50, and you have to convert this into degree measure. So it is 180 upon pi is to be multiplied by it. 0, 0 gets cancelled. You're left with 63. So 1118 upon 5 into pi. This is 11 into 18 upon 5 pi. We'll substitute the value pi as 22.7, which is given. So 11 into 18 upon 5 into 22. 7 will go up. 11 to 9. So 63 upon 5. This is your theta value in degrees. Now you can try and convert this into seconds if you like. This will be equivalent to 12, 3 upon 5 degrees. This is 12 degree into 3 upon 5 into 60, which is 12. This is 12 degree, 36 minutes. This is your final answer. Next. In a circle of diameter 40 centimeter, the length of the chord is 20 centimeter. Now, instead of the length of the arc, a chord length is given to you. Chord is any line, any line segment joining any 2 points of the circle in its interior. Any 2 points on the circle can be joined by one and only one chord. Chord is always inside the circle. The internal measure. So let's draw chord of the circle. This can be considered as a chord of the circle. The diameter is given. That means circle has a diameter of 40 centimeter. We know that diameter is equals to 2r. So if this diameter is equals to 40 centimeter, so your radius will be equal to 20 centimeter. Chord length is also given as 20 centimeter. Let this be the center of the circle. Therefore, you can draw the radii over here, joining the endpoints of the chord. Let's name all these 3 points. O is the center, AB is the chord. Let us consider a point over here, C. Find the length of the minor chord of the minor arc of the chord. Now, this chord divides the circumference of the circle into 2 arcs. One major arc, let this point be D. So ADB will be the major arc and ACB will be the minor arc. You have to find the length of the minor arc. Let this arc length be equal to L. Let L is equals to ACB arc. Now, arcally, you draw a curve on the top of any 3 points with which you name an arc. This you have to calculate. We know that the radius given is 20 centimeter. This is also radius 20 centimeter. By observation, this is an equilateral triangle which makes this angle as 60 degree. Angle of an equilateral triangle is 60 degree. If this is 60 degree, this is your theta value. Now, theta has to be in radians. So you have to convert 60 degree into radians. We know that 60 degree is equals to pi upon 3. Or you can multiply it by pi upon 180 and then come up with pi upon 3 radians. However, you should memorize some standard degree into radian conversions. Also, radius is equals to 20 centimeter. We know that L is equals to r theta, which means r is 20 into pi upon 3. Now, in question, it doesn't mention whether you have to take L as, pi as 22 upon 7 or 3.14. Nothing is mentioned. So either you can leave this as it is, or you can place any of those two values, 22.7 or 3.14, and come up with the decimal value. The unit, however, of length will be centimeter. Unit will be seen as the radius unit. Next. One second. If two circles arcs of the same length subtend angles of 60 degree and 75 degree at the center, find the ratio of their radii. So two circles are given to you, and both the circles have the same length of the arc. So L1 is equals to L2. For circle 1, we are considering R1, L1, and theta1 as the radius, length of the arc, and the angle subtended by the arc. Same goes for L2, R2, theta2 for second circle. We are given that L1 is equals to L2, L1 is equals to R1 theta1, and L2 is equals to R2 theta2. So these two will be equal. Lengths of the same angle, same length subtend at angle of 60 degree and 75 degree. So this is R1 into theta1 is 60 degree. Now theta is supposed to be in radian. So you'll have to convert it in radian by multiplying by pi by 180 degree is equals to R2 into theta2 is 75 degrees, 75 into pi upon 180 radian. These two directly will get cancelled. Okay. Now, therefore, R1 upon R2 is equals to 75 upon 60. This is 15 into 5, 15 into 4. So we have 5 upon 4. You have to find the ratio of their radii. So observe that initially you consider this as first angle, so theta1, and this as second angle, theta2. That means you are in your question, length of first circle upon second circle is given theta2. First circle upon second circle, and their radii means first radii upon second radii. R1 upon R2 is to recalculate. Next. Find the angle in radian through a pendulum swings, through which a pendulum swings if its length is 75 centimeter and the tip describes an arc of length. 3 lengths are given to you. Let's consider the first length. Find the angle in radians through which a pendulum swings if its length is 75 centimeter. So length of the pendulum is given as 75 centimeter. Let's draw the pendulum. Pendulum can be something like this, and let it swing along this value. This is how the pendulum is swinging. So if this is the length of the pendulum, according to the swing, according to the sector which is formed, this length of the pendulum becomes its radius. So this is given to be 75 centimeter. Same, this will also be 75 centimeter. Let this point be O. This is A and this is B. So pendulum OA is swinging from OA, its original position, to OB position and back. And the tip describes an arc of length. So this is the tip, and this describes an arc of length. Find the angle in radians through which the pendulum swings. This is the angle, theta. So for 3 different swings, 3 different arc lengths, you'll get 3 different values of theta. Let this first value be equal to L1. So L1 is equals to 10 centimeter. You have to find out the corresponding theta 1. We know that L is equals to R theta. So L1 is equals to R theta 1. Therefore, theta 1 is equals to L1 upon R. So L1 given is equals to 10. R is 75. 2 upon 15. Divisible by 5. This is in radians. It's given in the question that you want the answer in radians. Second, R is equals to 75 centimeter. L2 is equals to 15 centimeter, and you have to find theta 2. Again, L2 is equals to R theta 2. Theta 2 is equals to L2 upon R. So it is 15 upon 75. 15 1, 15 5. This is 1 by 5 radians. Next, R is equals to 75 centimeter. L3 is equals to 21 centimeter. Theta 3 is equals to question mark. L3 is equals to R theta 3. Theta 3 is equals to L3 upon R, which is 21 upon 75. 3 divisible by 3. 3 into 7 is 21. 3 into 2 and 5. So this is 7.5 by 25 radians. This concludes this exercise. Thank you.